This lesson deals with supplemental problem 212. You can find this problem in the course ebook in the Chapter 2 Supplemental Problems on page 13. This supplemental problem deals with a property called the parallel resistance constraint. Let me just read it. If K resistances are in parallel, then the equivalent resistance is smaller than the smallest resistance of the parallel combination. Now, why would that be true? Let's take our definition of parallel as 1 over the sum of 1 over each of the resistances, suppose that there's K of them. Since I can call any resistor R1 or R2 or R3, let me call R3 the smallest resistance in this parallel combination. Now let me take this equation for R equivalent and pull out R3. Now since there wasn't an R3 in each of these other terms, I need to put that back. Here's R3. When I multiply this, I'll get 1 over R1. Put an R3 here. Of course, there was a 1 over R3, so I pulled that out, and I just have a 1 left over. And all the way through resistor R sub K. Is that less than R3? Well, let's do a little more algebra. Let's bring this R3 up into the numerator, and then let's divide both sides by R3. It'll leave me with a 1 in the numerator, and then R3 over R1, R3 over R2, 1, all the way through R3 over R sub K. Now, is that less than 1? Well, yeah, I have 1 divided by 1 plus something, so that's got to be less than 1. This is a very handy property when you're doing parallel combinations on your calculator, and you get a result, and you assume it's correct, but if you look at it, this can help you find a mistake. For example, if you took 1K in parallel with 1K, suppose you found that the result was 2K. Well, that can't be possible. It's got to be smaller than 1K. Now, there's a similar property for series resistors that's kind of obvious, and I'm just going to state it here. And that is if K resistances are in series, then the equivalent resistance is larger than the largest resistance of the series combination. Of course, you're going to take the largest resistance and add something to it, so it's going to be bigger than the largest one that you have. And these are two properties that are handy to do when you're doing series and parallel combinations, and this is supplemental problem 212.